was recognizing that, for example, sorry, I gotta hook up the tablet. So if you had a, come on, there you go. So if you had a square, right, and you knew the area was, I don't know, 25, can you tell me what the side lengths are? Well, that's easy, because if it's a square, we know all the sides are the same. So this times this gave me the area, right? To find the area, it's side times side. So what two numbers do we multiply to give me the area 25? Well, that's easy, it's 5. Right, so, I don't know, I'll do a couple more. So what if another square here, and somebody told you the area was 144 square units? Now, obviously this was a 12 and a 12. Right? So the side length of that square that gave you an area of 144 was 12. But what if you had a square where it's not a perfect square, the number is not a perfect square. So let's say you had 13. What number times itself, right? What two numbers here did I use to give 13? Well, if you go to, as much as you try, right? And we did a few problems here and trying to approximate, so square root of 13. And if you said, oh, that looks about, I'm going to round it to 3.6. No. Let's multiply 3.6 times 3.6. 3.6 squared, it's going to be 12.96. Not exactly 13, right? So let's extend that decimal. Let's say 3.6055. Let's use that decimal. Times 3.6055, 3.6055, and notice that you're going to now 3.60, sorry, 3.6055. That's what I get. I get 12.99963025. Again, this one is even better because it's even closer to 13, but not exactly 13. So, but one way we found out to write this is to write it as a radical. So we write this, instead of writing this ugly number, and by the way, this number goes on forever and ever, right? I approximated this, so these are not even precise numbers, right? So if you put the square root of 13, you're going to get a long decimal, a rational number, right, a non-terminating, non-repeating decimal, and still not equal to 13. It's going to be 12.9999999 forever and ever. So the better way is to write it like that. Right? So, and if you multiply square root of 13 times square root of 13, guess what you get? You get 13. Okay, this is the better way of writing instead of writing a long decimal. Okay, this is a more precise way. So that was your lesson today. So let's do this one. The square has an area of an 81, so imagine the square. Select all the expressions that are equal to the assignment. So I know this had to be a 9, and this had to be a 9, right? 9 times 9 gives you 81. So A is not it. 81 divided by 2 is definitely not it. What's the square root of 91? Square root of 91, square root of 81 is 9. So this, yes, because 9 and square root of 81 mean the same thing. Square root of 9 is definitely not. And 9 was a yes. So C and E are good. So here's a square, and they're saying, hey, the area is 37 square units. What are the sides? What are the sides? So notice that the sides have to be the same. So in this case, when it's not a perfect square, it's going to be square root of that particular number of the area. So square root of 37. Because if you multiply square root of 37 times square root of 37, guess what you get? 37. So the answer here is square root of 37. What if the area was 100 over 9? What two numbers did I multiply to get 109? Well, that's not that hard, right? Oh, it's going to be 10 over 3. 10 over 3. 10 times 10 is 100. 3 times 3 is 9. So this was 10 over 3. And this is 10 4. What if the area, now go back, there's a square, they told you the area is 2/5 square units. Well, we can just write it as 2. Square root of 2 of 5, square root of 2 of 5. And the last one. I wonder if they, what kind of answer they want here. The last one says, hey, the area is 0.0001. So what are the two numbers that I multiply? Well, let me see. 0.01 times 0.01. How many zeros does this have? 3. So this is actually not bad because it would just be 0.01 and 0.01. If I multiply these two, I get the answer that we want. Here's some information about 3 squared. Determine which side length matches each square. What the heck? Say what? Square A is smaller than square B, so I'm going to draw that. Here's square A and square B. I'm going to put it over here. It's a little smaller. And square B is smaller than square C. Let me shift these two over here. And square C, square A is smaller than square B. Square B is smaller than square C, so I guess this is the order. The square side lengths are, so this is the side length of square root 26. Sorry. If the side lengths of one square is square root 26, and if we multiply it out, that means the area is 26. The other one is 4.2, so if I multiply by 4.2, that's 4.2 squared. It's going to give me 17.64. And the other square has length square root of 11, so if I multiply square root of 11 times square root of 11, I get 11. So the order, right, so square root of 11, that's the smallest, so this guy has square root of 11. The middle one is 4.2, so this measures 4.2, and the large one, this measures square root of 26. Here's a square. Okay. Here's a square. The side length is 1/5, which means this is 1/5. So what's the area? It's 1/5 times 1/5, which is 1/25. This one is another square, and this measures 3/7. This measures 3/7. So 3/7 times 3/7 is 9/4. And here's a square. This measures 0.1, and this measures 0.1. So if I multiply that out, 0.1 times 0.1, I get 0.01. Which expression is equivalent to that? So, well, remember, bases are the same. We can add the exponents. So 12, and I'm going to add the exponents. Should get 12 to the -5th power, or remember, when it's negative, we're going to write it as 1/.
Please pardon the interruption. Will student Anthony Chiros from 832 please report to the main office?
And when we do that, we write it as 1/12, and we change the negative to positive. So either this or this. No, no, and yes. And no. Okay. And 13 and 14, you get skipped because we haven't done scientific notation.